Now today I want to discuss two things. The first one is so again for the solution, you can have it tomorrow, okay? Just go and find your TA. So he's in the 5th floor. You get out of the elevator, okay? So suppose that this is the elevator. You get out, go to your right, and his office is in the 2nd door. Just knock the 2nd door, okay? You'll find him. Okay, so so yesterday we motivate the multiple regression in this way. So we like to add more independent variable because otherwise we may have the omitted variable bias, right? So one way to avoid it is to include that potentially omitted variable, x2. So today, one thing I like to show you is meaning of beta 1. What is it? It's the effect of x1 on y holding x2 constant. So what is new is this part. So I try twice. I show you for the first try some kind of calculations, but it's not that meaningful. So I try again and give you some examples. Okay. So what's the meaning of holding x2 constant? So in this exercise, so what we have in mind is a circumstance like this. So we have multiple independent variables that influence y. So in this exercise, what I have in mind is I increase my x1 by small amount but I don't change my x2 at all. It stays the same. Okay? Then my question is, what is the changes in y? And here it says that's beta 1 times changes in x. Okay, so let me show you some kind of calculation, but it's not that meaningful though. So let's say that the value of y is determined by the regression line. According to the regression, your outcome will have this much value. So in some sense, this is before change, and this is after change. Now we subtract them. So there's a cancellation. Most of these terms will be cancelled away. What is left is this, right? And there's nothing left for this term. So what is beta 1? Changes in y. If you change your x1 by 1 unit, is it the effect we like to know? if you analyze something, some data, is this the effect we want to know? Let me give you some example. Now suppose that, so this is my first example, okay? So you want to buy an apartment, a house. Y is the price of an apartment, of a house. And X1, what is important for an apartment? A lot of things are important. Maybe size is important. So let's call it X1. And what else is important? Maybe number of bedrooms, number of rooms. They're important too. So, size affects the price of an apartment, and the number of rooms affect the price of an apartment. So suppose that you like to compare two options, okay? You want to keep the same number of bedrooms, like 3. That's what you want. So you have a family of 3. So three bedrooms are enough. But, you just want your house slightly bigger. Okay? So in that sense, what you want to have is increase the size of your planned new apartment, but keep the number of rooms constant. Okay? And then you ask, what is going to be the price of such change? Now, so that's this effect. So I change the size of my house while holding X2 constant, keeping the number of rooms constant in my calculation. Okay? So if you want to know that kind of effect, so we call it a net effect. This is the net effect. Or the mathematical term is partial effect. The opposite word of the partial effect is the total effect. Now the point is this. So regression is useful if that's the kind of question you like to know. Okay? I want to keep everything else constant. Number of bedroom, number of bathroom, everything else constant. I imagine that only the size of the house increase slightly. Okay? Then what's going to be the changes in the price? If that's the kind of question you like to know, then regression provides the answer. The regression coefficient. If you just read the regression coefficient, it tells you the net effect. The thing is that if you don't have any regression, and if you don't understand it, then this net effect is kind of tricky thing to figure out. So what is usually happening in the data, the real world, is if you increase your x1, if you change your x1 slightly, they usually change everything else. Because in the world we live, the covariance between x's are quite strong. So in this example, it's of course positively correlated. If you take a look at the bigger houses, they usually have a lot more rooms, right? So if you're not careful, it's kind of difficult to figure out this net effect. If you're just being very naive and you collect small apartments, small houses, and figure out their size and their prices. And you compare it against bigger apartments, bigger houses. You figure out the prices of those houses. And of course, the second group is much more expensive, but it does not tell you that it is because it's bigger. Maybe it's because it has more bedrooms, right? So if you simply compare two groups, the prices of those two groups, you never figure out why the second group is more expensive. Is it because of the size? or because of the number of edges. That's kind of tricky one. Okay? So to get the net effect, one VG method, you just run a regression. Okay, let me give you a second example. Somehow, my first example didn't go as I planned. Okay, let me try it again. There's nothing wrong. It's just not that very effective. So the second example is y. What is it? So let's just say that it is wages. And my x1 is education. So let's use the example we used yesterday. And x2 is ability. Now we know that education affects wages, ability affects wages, but they're also very much correlated, right? So unless you're careful, if you're not careful, maybe you can just collect two groups of people. One is less educated, the other is more educated. And if you just compare their wages, it actually does not tell you anything about the effect of education. Because the second group, more educated, have two things. They have more education, and on average, they have more ability. So simply because they get paid more, their wage is higher, does not mean that it is because of the education. Maybe it's because of the ability, right? But what we like to know is the net effect of education, holding ability fixed. Assuming that the two groups have the same ability, then we simply ask, what if I ask somebody, some random person, to get more education? What's going to be the net effect? That's usually the question we like to ask, right? So even in that case, what we need to know is this net effect, and that's given by the regression. Okay, I hope it's better. Is it clear? Okay, then that's it. I think I just finished this day 17, and there is one topic, constant regressor, but I think you can read it, okay? So please take a look. It only has 4 lines. So I think you can take care of this. Now, from now on, what I want to have is to have an R session. So let's open your computer. Think about this example again. So just in case. So suppose that you run the regression and you present your research, okay? So you says 1 more year of education increase wages by 10%. And if some people ask, it is maybe because they are more able people, okay? So they just apply this omitted variable bias type criticism to you. Then what you can say is, so it is important. I include the ability in my regression, so its effect is completely controlled. Okay? So it's not a criticism anymore. So that's the meaning of having this net effect. So if your regression says 10% increase for the education, and if you have ability in your regression model, then what you're doing is you're comparing kind of hypothetical two groups. And in these two groups, you can safely assume that they have the same ability. Okay? And the only difference is education. So comparing their means by regression makes sense. Okay? So that's how you respond. Okay, so today I want to show you something quite cool. In the regression, we already did. So you know something about this. But today I'm going to show you how to apply it in regression setup. And that's conditional selection. So let's review what we already know. So let's generate this variable. Do you remember this commuting time example? This was one of the homework exercises. So suppose that you have commuting time from 10 minutes to 100 minutes. By selection, what I mean is you can ask questions and I'll produce true or false, right? You can ask questions like this. And we use this true false outcome as a way to select only some partial elements in the original variable. So this is what I mean. You probably remember this. So show me our commuting time that is longer than 50 minutes, strictly longer than 50 minutes. So it reports the thing only when this condition is satisfied. Okay. So what is the commuting time which is equal to 40 minutes? Of course it's 4. Not equal to 40 minutes. Everything else, right? And you can say commuting time, where commuting time is greater than 4 and less than 8. So you can mix them up, right? You can make your questions kind of complicated. What is commuting time which is smaller than 3 or bigger than 8? So you can give a condition and ask R to choose your variable, data, sample, whatever, only when that condition is satisfied, right? And the name was conditional selection. So today, we'd like to know how to do this in regression. Okay, so let's read the data set. Let me change my working directory first. And I wanna use this California school data set. So let's apply this conditional selection idea to something easier, okay? We just compare the test scores, the mean test scores of two groups. So the first group is the school size is bigger. So they tend to be in a large cities, okay? The second group is the school size is much smaller. They tend to be in a rural area, okay? So let's compare those two groups. In this variable, perhaps I can use this one, the enrollment total. Basically, this is the total number of students in a school. So let's use it. And let's compare the mean of reading score, math score. So to use that enrollment total, I need to figure out its distribution. So the median is 950, mean is 2,600. So mean is much bigger than the median. So it means that we have some quite large outliers out there, right? Okay, so maybe we can say, what is my math score for the small classes? So how to define small? Maybe the number of students less than the median. Now if I type enter, and I'm going to see a lot of those math scores, right? And it doesn't tell me much, so maybe I can just ask to see the average math score of big schools, okay? And then you can compare it against, so mean was 2,600. So let's say 2,600 is our cutoff. So this is my average math score for small schools, 653. And this is my average math scores of larger schools, which is slightly lower. Now, if you want to know more, maybe you can use summary function, right? So the average math score is higher for the smaller schools, and the median score is higher too. And the first and third quartiles are higher. So we kind of understand a little bit of things, right? Now, what if I want to see what is in the middle? So far, I have kind of very small schools against very big schools. What if something in the middle? Then I can make my condition more complicated. It's bigger than small number, less than the big number. So that's the math course for the medium-sized schools. Oh, it's kind of impressive. So they have the highest average and highest median. The first quartile is slightly lower. So something like that. So that's how you compare different groups. Now, so far we only use the numbers, right? But it doesn't have to. So for example, this county variable is it's just name of all the counties. Like, so this is the kind of boundaries of, how can I say, kind of cities or collections of cities. This is not numbers, right? It's character. So how to use this character and select those observations that belongs to some characteristic, that belongs to some county. So you can say this, county is equal to, for example, Los Angeles. When your input is a character, you have to put it in the quotation mark. So you have 1 true and 2 true. Oh, you have more than 2. So there is some school district that is in the Los Angeles County. And of course, there are a lot of schools that is not in the LA County. Okay? So we can use it as our conditional selection. So I can put it as a condition, and then I can ask what is the math score of every school that is in the Los Angeles County. And of course, I need something like summary or mean. So there's a summary of math scores of schools in the LA County. And this is the summary of math course of all the schools that is not inside of the LA County. So as you can see, in the LA County, the mean is lower, the median is lower, and all the quartiles are lower. It's in a big city, and the public schools, they are, at least I can say it's not excellent. Okay, so that's how you find out summary statistics of different groups. Okay, just provide conditions. Now, how you run a regression and use this condition. So let's say math score is explained by student-teacher ratio. But when I run this regression, I only like to use the schools in the LA County. Okay, so I like to use being in the LA as a condition, conditional selection. So how can I do that? The option in LM function is subset. So remember this. It's kind of long, but can you type it? So that's the regression for schools in the LA County. And this is the regression for the schools that is not in the LA County. So that's one way that you compare effects across two groups. So let's take a look at these numbers. What do you find? So if you reduce your class size by 1 in LA County, what is the gain? It's about 5 points, right? On average, the test score goes up by 5 points. What if in the schools not in the LA County? It goes up by 1.7 points, right? So effect is much stronger here. Now suppose that you make this decision. So suppose that you are the governor of California and you only have a limited budget, okay? $1 million and that's it. So where do you want to use this money? Suppose that you only care about the total utility or whatever, okay? You don't care about who. As long as the total utility goes up, then you're okay with it. And the analysis like this kind of provides you an answer, right? Maybe you should spend it in the most effective area, which is in LA. It happens to be. Now let's do this kind of exercise again. So this time I use different condition, but maybe my enrollment total is very small. So this is small schools. And this is big schools. Let's make it more dramatic. Oh, it's not that dramatic anyway. So effects for reducing class size in a small school is less than 1 point. Big school is more than 1 point, right? Kind of makes sense, right? The school is already kind of small. Then we can expect that average gain will be small, right? But anyway, you can still ask the same question. If you only have a limited budget, where you want to spend your money? And analysis like this provide an answer. Now, so we use this variable quite often. This is the percentage of students who take English class because they came from another country, okay, immigrants. So let's do this exercise using this variable. The median is 8.7. So let's say that for a maybe 5% of students whose native language is not English is kind of small percentage. Oh, I misspelled it. And third quartile is 22%. So let's say 23%. Oh, really? How about 30%? Okay. How about 40%? No, it's not very, the signal is kind of weak. Anyway, again, you can use this condition selection, and then you can run 2 regressions and you can compare size of the effect. When you do the analysis, write some report, something like that, this is one of the things you want to do quite often, right? So can you imagine that you're saying that the average effect of everybody, the whole population, is this much. But maybe we can divide up those population into smaller one, and then you want to present who has the biggest effect, and who has the smallest impact. Okay? If such discussion is useful, that's how you do it. So suppose that there is a law or something like that, and then you run 2 regressions, one for man, one for woman, and compare the effect. One for young and one for old. Okay? One for developed countries and one for less developed countries. And then you can discuss why that's important. So things like that. So this is very useful. Do you have this lecture notes? 18? In the second page, in section 3, so I gave 2 methods. The method 1 is to use this subset option. And method 2 is to make a new variable and run a regression with these newly defined variables, okay? So just to make the conversation complete, let's do it. Let's do the second one. So here, so the question is how to run a regression like this for the LA County, a subset, in a different way. So you can say my new y-get math score. Let me do copy and paste. You don't want to type the whole thing. Actually, you don't need this parenthesis. So my new y gets math score only when the county is in Los Angeles. Okay? And the length of this new y should be much smaller than length of my original y, right? Because only 27 schools satisfy this condition. My new x str So somehow I throw almost all the data point away. I only keep 27 because they are the schools in the LA County. Okay, they satisfy these conditions. And then I can run a regression. My new y against my new x. And of course, that should be exact the same as the regression we learned before. Okay, probably not right now, but later, I'll give you some exercise, some homework exercise. You have to use this kind of option, okay? Because it's quite handy later. Do you have any questions? No? Okay, let's call it a day. So see you next week.